And using these unit conversions, that's how we can convert between the systems. So for instance, that's how we can convert from pounds to kilograms. We're going to use this fraction or this one. And don't worry, you don't have to memorize this because it's in the notes. So this column's also in the book anyway. Okay. All right. So with these unit conversions, we can convert between the different systems, like between gallons and liters, quarts and liters, that kind of thing. So as an example, let's say we want to know how many yards are there in 500 meters, okay? How many yards are there? Well, if we go back to this, we want to know how many yards there are, and we're given meters, right? So we're going to want to use this here, as you can see. Okay, but now the question is, which of these conversion factors are we going to use? Well, if we want to go from yards to meters, right? That is, we want to fill in this blank. We want to make sure meters is in the denominator. Right? If you remember, if you go back to the factor label method, with any unit conversion, what you start out with is in the denominator. What your answer will end up in, what it will end up in is in the numerator. So we start in meters, we're going to end in yards, we're going to use this one. Sorry. So this is why we use this conversion factor. I mean, whatever's in the denominator is what's going to cancel. So we start in meters, and we want to end in yards. So that's what we do. We just multiply. Okay, when you multiply, what happens? Well, you have cancellation. Okay? So all we're left with is yards. And so we get 500 divided by times 1 over 0.9144, which is this, yards, which turns out to be about this. But that's what it is. So again, whatever's in the denominator is what you start with. The unit you end in, that's what goes on top. Okay. So that's why we multiply by this conversion factor. Okay. Here's another one. This one's a little more involved, but it's not terrible. So here, this is a problem from the textbook. So we want to know, given this information, you have someone riding a bicycle, they ride 5,500 meters, they take a break, and then they ride another 4,000 meters. First, we want to know how many kilometers did the bicyclist ride? And then we want to know how many miles they rode. So it's basically two conversions are happening here. Okay. So first, to be able to figure out how many kilometers there are, well, let's first figure out how many meters the bicyclist rode. Right? He rode 5,500, took a break, then he rode 4,000. Well, in all, he rode about 9,500 meters, right? How much he rode altogether. So really what the question is asking is, how many kilometers is 9,500 meters? So we want to know how many kilometers the bicyclist rode, right? So we want to know how many kilometers this is equal to. That's really what we're asking. Okay. As you can see. Now, how do we do this? Well, again, this is just like what we did earlier today with the metric system, right? we have 9,500 meters. We want to convert that into kilometers. Well, how do we do that? Well, we're starting out in meters, right? We see that kilo, right? If you're in meters, there's no prefix. You're here. For kilo, that's 1, 2, 3 units to the left. So since it's 3 units to the left, what we're going to do is we're going to move the decimal 3 spaces to the left. So we have, this is our number, okay? So we want to move the decimal point, which is after the last 0 here, 3 spaces to the left. So we go 1, 2, 3. So we're going to get 9.500, which is 9.5, and that's what we get. I mean, you could solve this kind of metric conversion, I guess, using unit conversions. I know they do that in the book. I just thought this would be a little bit easier. At least I hope it is. Okay. So we get 9.5 kilometers. Okay. So now we want to know, remember, if you go to the rest of it, how many miles did the bicyclist ride? Okay, well, we know he rode 9.5 kilometers. We just calculated that. Now Now we want to figure out how many miles he rode. In other words, we want to know this. So again, we want to know how many miles the bicyclist rode, given that he rode 9.5 kilometers. Well, I shouldn't say given, because we just calculated that. So in other words, we want to fill in this blank here. We want to know what number goes in this blank. Okay, so we have to use a conversion factor, right? Okay, let me hold on, let me just get to that table. Here we go. Right, so we have kilometers and we have miles. Okay, so we know it has to be either one of these two, right? But you start out in kilometers, you end in miles, right? So we're going to have to use this one. I mean, if you did try multiplying by this one by mistake, your answer would be kilometers over miles. Your answer would not be in the right units, and that's how you know that's how you would know you're wrong. Let me get to it. Here we go. So we're going to have this unit, this conversion factor we use, and we just multiply. Okay. So when we multiply, right, the kilometers, that's up here, it's down here, so they're going to cancel. And what we're left with is 9.5 times 1 over this, which is 9.5 over 1.6093. And when you do this quotient, you actually end up getting this. Oh, sorry. That's really what it boils down to. Again, we're just multiplying. It's kind of like when, how do I say this? It's kind of like if you want to know how far you drove, right? If you're driving 25 miles an hour, how do you figure out how many miles you drove? You just multiply, right? By how long you drove. If you're driving 25 miles an hour and you drove for an hour, you went 25 miles, right? If you drove for 2 hours, you have 25 times 2, that's 50 miles. That's all. It's the same idea. So, all right. Okay, let me ask, yeah, well, oh boy, all right. Let me stop sharing this. Here we go. I have a worksheet that people can work on. Okay, let me just pause, let me stop this.